Here we see a hot piece of metal. A blacksmith has just formed this metal into its shape, and to cool it down, he or she dips it into some water. In the moments after the photo is taken, what temperature changes would you expect for the metal and for the water? They both change temperature. So the metal, when it's dipped into the hot water, and this is just water that's sitting outside, it's not especially hot or cold, it's whatever the air temperature is outside. When the metal is dipped into the water, the metal cools down and the water heats up until they both reach the same temperature. This state where they're at the same temperature is called thermal equilibrium. Okay, thermal equilibrium is when the everything in the system is at the same temperature. So you dip the metal in, the metal gets cooler, the water gets warmer until they both reach this equilibrium temperature. The red hot metal is placed in the water and allowed to sit for a long period of time. Which statement best describes what happens to the temperatures of the water and the metal? This is, of course, referring to some statements in your book. And as I said, the metal cools down, the water warms up until they reach the same temperature. Now, there's a lot more water here than there is metal, and that's by design, that's intentional. That is so that the metal will cool down more than the water heats up, and then the metal will be something that the person can handle afterward. The term heat is common in everyday language, so people use heat all the time. But heat in physics heat in science has a specific meaning. You may have encountered this again if you took a chemistry class before. You may have encountered this definition, and we use the same definition in physics because the scientific definition of heat is the transfer of thermal energy. So in the boiling water, we have thermal energy being transferred from the burning fuels, to the container, to the glass container, to the water itself. That is heat. Okay, the heat is the transfer of that energy from one place to another. The heat lamp generates heat because it uh, it transfers energy from the filament inside the bulb down to ultimately to the chickens to keep them warm. And in the stove coil, the stove is heated by electricity, and which generates resistance, which has the coils have resistance, and then the the stove coil gets red hot. It transfers energy. In this case, it just transfers thermal energy to the air. But if you put anything on there, then it will transfer energy to that object as well.